Hello and welcome back. In this video, we want to look at the mean value theorem for integrals and apply it to a simple problem with a cubic function on a closed interval. So the mean value theorem for integrals states that if you have a continuous function on a closed interval, then there exists a value of c in that closed interval such that the integral of that function, the definite integral, is equal to f of c times b minus a. And so for us, we want to go through and apply it to our problem. So we're going to need to find the ingredients for this. So first part of this is to find the integral that we're looking for. So that's going to be the integral from 0 to 2 of our function, which is x cubed with respect to x. So that's going to give us a 1/4 x to the fourth evaluated from 0 to 2, which is going to be just 1/4 of 2 to the fourth minus 0 to the fourth, which is just 1/4 of 16, which is just 4. All right, so now we're going to take that value and set that equal to f of c times b minus a. And in this problem, b is 2, the endpoint of the interval, and a is 0. So we really have 4 is equal to f of c times 2, or f of c is equal to the value of 2. All right. And we see that f of c is just going to be c cubed. So we're going to have c cubed equaling the number 2. And if we take cube roots of both sides, then we end up with the cube root of 2 being that value. And if we think about it, that number is inside the interval from 0 to 2. It's a little over 1. And if we think about what's happening here, this is the value of c, where that integral is equal to that value times the length of the interval, which is 2. And of course, you could check this algebraically, and you could also look at the graph of this. And in the guided notes, you will see a graph of this as well.